All right, when we last left off with part one of this video, we were in this state where we had just a simple setup of the power on our breadboard powering this LED. And the next step in our series, we're working towards having an IoT light bulb controller. And so our next step is to add a button that will control the light on and off. So to get kind of started with this, we can even set this button up kind of similar to how we have our power, to where when we push the button, the light will turn on and off with just power. Once again, we're just going to kind of leave the controller as just a power source at this point. So if we put the button on here like so, we can actually just change the power to go from, instead of going directly in towards the resistor, we can actually just have it go right from here on the side, just like we had it before, but into the top of the button. And then the bottom of the button then would, once we push this down, that switch would activate and the power would then feed back through, just like we had it before, keep in mind. But this time the button's actually controlling the flow of power. So if we push this down, you see that our light bulb turns on, and we let it go, the light bulb turns off. Now you may be wondering, why do I have to feed the power in on the top versus, can I just have them both on the top? Well, the top and the bottom are connected on each side. So it runs straight across here and it runs straight across there. So actually, if I move this to the top, it's just always going to be on, because that flow, the top of the button is bridged and the bottom is as well. And so in order to act as a switch, you actually have to put one at the top and one at the bottom. And then when you push the button, then that will act as kind of the switch. So that works out pretty well, obviously. But at the end of the day, we're going to need the microcontroller controlling the light. So we're going to go ahead and enter some code now. We're going to switch over to the computer. Let's get some code pushed up, and then we'll wire this up for that.
So to get our first code pushed into our ESP32 microcontroller, I'm going to use the Arduino IDE. So like it says, you basically use it to write code and upload it to the board. Supports Windows, Mac, and Linux. So uses some C++ libraries, super simple for a beginner to use. So arduino.cc, you can download the IDE from there or use their web as well. I went ahead and downloaded this. I'm running this on Mac. And the first thing you'll have to do when you set it up is to actually get it configured for your driver. So if you look here, like your board, it comes pre-configured with a lot of Arduino boards, obviously. But you can use other boards with this, and actually what you'll have to do if you do not have an Arduino board is come into the boards manager. Like mine, for instance, I had to look for a Heltec board. So just come in here, search, you can find the drivers, and then when you connect, your board should be good to go. There's probably further instructions from whichever board you've downloaded, or you can just search online to get you up and going. You can see that mine is already set up for that. One of the nice things about Arduino IDE, besides it being very simple to use for a beginner, is that they already have kind of some examples built in. So you can see when we're going to be using a button, this is perfect because it already has that, and I've got it open here already. I'll go ahead and pull this up. So I did change some of the inputs compared to the examples just because I have shorter wires. One of the things you'll need to note about these button inputs is that not every pin on your board can be used for this, okay? And so you'll want to look at a diagram of your microcontroller and make sure that it's not something like just input only. Some of the pins are reserved for the board, some of them are input only. So you want to just make sure that when you're doing it, you can't just pick any pin you want necessarily. Make sure you verify that these pins will work. The two parts to know is that the setup is going to run first, kind of your initializer, and here we're just basically setting the pins here. These are just the variables for our numbers. Here we're actually setting the pin modes as inputs and outputs. And then after it runs the initializer, it's right away the program's just going to run this loop, and this loop is infinite, and it's just going to run over and over again, and all the code inside of it is just going to continually repeat. So this is acting as kind of like a listener in a way. It's going to go through, it's going to check the button pin. If the button pin is high or 1, because in digital it's either 0 or 1, if it's 1 or it's pressed, then we're going to turn the LED on, okay? And otherwise, we're just going to turn it off or on low. So let's go ahead and just see this in action real quick and see what that looks like on our board.
Okay, so before we push our code to the board, let's just take a look at how we're gonna kind of wire this up. Much like we had before, our power is still coming out of the microcontroller into the top part of the button. And on the bottom part now, instead of going towards the light bulb, we're actually gonna go to the button pin that we specified in the code. So in my case, I've set the button pin to 2. And if you look at the side of the board here, sorry, it's a little hard to tell, but this is actually 2, okay? And so we're gonna set it up that way. And then the second piece of the puzzle then would be the LED. And the LED would also be set up pretty much the same, except for now we have this set up to our LED pin. In this case, I've set it to 21, which is in here. 21 down to the resistor, and everything else is still the same. So everything is still set up exactly the same as we had it, except for now instead of everything kind of just going through the power, everything goes in through the pins that we specified. And in the top left corner, the second button over on our IDE, there's a button to just push our code. I've already done that, and if you can see now that I push the button, the light turns on. If I let go of the button turns off, okay? And so this is the exact same state, but we're starting to evolve now, and instead of the button just having power, we're actually having the microcontroller control it. The only thing we're missing really to complete this very first part is to have state, okay? So that's going to be the next part of code we're going to look at, is add some state so that the microcontroller controls whether the light is on and off and controls it that way. So when we push the button, it'll stay on, and we push the button, it'll turn off. So let's take a look at what that code will look like.
Okay, so we're back in our Arduino IDE, and I've made a new file with some of the same code from our last example. Building off of that, we're going to go ahead and add some state. So let me just go over kind of some of the changes I made. I'll post this on GitHub, so anybody following along could download this and try it out. I did have to change one of my pins from the previous example because must have had a bad solder job on my part, and it was flickering. So I've changed one of the pins. Feel free to check your diagrams, make sure your pins are lining up and that they're the appropriate type. Once again, remember some of them could be just input only. So feel free to take a look at that and make sure you have that lined up properly. Next, we just kind of have some variables here. Our button state, similar to what we had on the last one. Last button state, we'll talk about that in a second. And then kind of a Boolean to keep track of the light being on or off. In our setup, similar, the exact same as the last one. We're just setting our inputs and outputs. In our loop, things are going to look a little different. So we first set a variable or button state to the pin. So let's say, remember, this is running over and over again pretty quickly. And so if I push the button down, okay, then we're going to set this button state is going to be 1. Now, the last button state was 0, so this case of them being not equal would evaluate and we would jump into here. Now, why is this line necessary? Remember that this loop is running extremely quick, right? And so essentially if I push and hold down the button without this line, this code is going to evaluate and it's going to go back again. And if we're toggling like we are here, it's just going to flicker. It's going to be totally off. So we just want to make sure that the state changed from pressed to unpressed and only evaluate it during that case. Um, and then, so we're also checking to see if the button has been pressed or if the button state is high. Um, then this code here is basically saying, okay, well, if the light was on, turn it off, otherwise turn it on. It's just a simple toggle, and you can see I broke these out into just some other methods with our, this is the same code we had last time for turning the lights on and off, and we also set the state of our variable so we can keep track of whether it's on or off, okay? So we only care when the button was pressed, because when we release, at that point, we don't want to check again, otherwise we're going to end up basically just doing what we did on the last example, which is turning the light on and off when we press and release. We only want it to say, hey, when I press the button, if the light was on, turn it off, otherwise turn it on. And then this line here was added actually from one of the examples of state on Arduino, and that basically allows it to keep it from flickering, because once again, remember, this is going extremely fast, so typically you wouldn't want to add delays, but you'll see a lot of examples in the Arduino IDE where they kind of add just a small little delay. They call it bouncing. So you just, if you were to take it out, you would see exactly what is happening. It just kind of flickers a little bit. And so we'll go ahead and add that. And then finally, we're just going to set the last button state equal to the button state here. So let's go ahead and run this code. Let's go ahead and push this to the board and see what things look like.
Okay, so we're back at our board, and we have the exact same setup, but now we have our new code pushed to manage state. And now you can see that when we push the button, the light remains on, and when we push the button again, the light turns off. So now we have full state with our light bulb, and what we'll be able to do now is start to communicate with our publish subscribe and be able to control this with a phone. So that'll be in the next part. We'll wrap up this light bulb in part 3. If you have any comments or questions, feel free to post them, and thanks for watching.